Hi, this is Jaya. In this video, we shall see the biography of Subramanyan Chandrasekhar. Subramanyan Chandrasekhar is a famous astrophysicist and he discovered that massive stars will collapse under their own gravity and they will reach enormous or even infinite densities. And today we call these collapsed stars as neutron stars and black holes. Subramanyan Chandrasekhar was born on October 19th, 1910 in Lahore, that is at the time of British India, and Lahore is now in Pakistan. And they were having totally 10 children, and he was the third in that family. And the whole family is a well educated family. His mother was a translator and she taught her children to read. His father was the Deputy Auditor General of the Northwestern Railways. The Nobel Prize winner physicist C.V. Raman was his father's brother. As a very young boy itself, he was homeschooled by his parents and private tutors. In 1922, Subramanyan Chandrasekhar became a student at the Hindu High School, which is in Triplicane in Madras, and he got educated there till 1925. When he was at the age of 14, he began studying for a physics degree at Presidency College in Madras. In 1929, at the age of 18, he wrote his first academic paper, The Compton Scattering and the New Statistics. The very next year, he graduated with a BSc Honours degree in physics. Since he had shown extraordinary potential in physics, he was given a scholarship to study for a PhD degree at the University of Cambridge in United Kingdom. His supervisor at the Cambridge was a physicist and astronomer Ralph Fowler. While travelling by ship from India to Britain in 1930, Chandrasekhar reviewed Fowler's and others' work on the degenerate electron gas in white dwarf stars. He also updated the classical physics using previously what was there to understand and the behavior of the electrons, and he incorporated that understanding with the new relativist physics of Albert Einstein. Although he was just 19, this work only led him to his Nobel Prize in Physics later on. In 1931, Chandrasekhar visited Göttingen, which is in Germany, and there he was invited to spend summer time working with the future Nobel Prize winner physicist Max Born. In 1932, Chandrasekhar moved again, this time to Copenhagen, which is in Denmark, and there he worked at the Institute of Theoretical Physics, which was founded. And later on, 12 years after that, Niels Bohr, who was there, won the Nobel Prize as a physicist. And in 1933, he returned to Cambridge, where at the age of 22, he received his PhD degree. And he was also awarded a fellowship so that he could continue his research at Cambridge for 4 more years. And between the ages of 18 to 28, that is from 1929 to 1939, Chandrasekhar was intensely interested in the physics of stars, which is called as astrophysics. Traveling by ship in 1930 to begin his PhD at Cambridge, he calculated a number, and that number is today honored, like it is honoring him, because that number is now called the Chandrasekhar limit, and the value of that number is 1.4. And this is the number which determines the fate of stars. And Chandrasekhar published his result in 1931 in the Astrophysical Journal. In several billion years, our sun will become a white dwarf. In 1930, astrophysics believed all stars would eventually fade to become white dwarfs. Chandrasekhar discovered that a white dwarf can exist only if its mass is less than or equal to 1.4 times our sun's mass. Chandrasekhar initially found the limit would be about 1.7 solar masses, but later on he refined his value and stated as 1.4. At the end of a star's life, if its remaining mass is greater than 1.4 times our sun's mass, then its ultimate fate will be rather strange. Chandrasekhar did not propose the existence of neutron stars or black holes, but in 1932 he wrote that for all collapsing stars of mass higher than the Chandrasekhar limit, there were no known forces that could prevent a singularity forming. For physicists, a singularity is a point with zero volume into which a star's entire mass has been crushed by gravity. Today, we know all black holes have a singularity at their centers. Unfortunately, Chandrasekhar's view was opposed by the foremost authority on the physics of stars at that time, that is Sir Arthur Eddington, who was also at the University of Cambridge. Eddington did not believe matter could be crushed to the incredible densities Chandrasekhar's theory predicted. After all, he was being asked to believe the entire mass of the moon could be crushed into the volume of large building or nothing. No, said Eddington, such densities were impossible. His emphatic view was that there must be some higher, undiscovered scientific principle which simply stopped incredibly dense objects being formed. Our modern understanding is that Chandrasekhar was right and Eddington was wrong. Unfortunately, although he won private support from eminent physicists such as Wolfgang Pauli, Niels Bohr, and Paul Dirac, they all agreed with his calculations, but they did not publicly support Chandrasekhar's conclusions. In 1937, his 4-year fellowship came to an end. Chandrasekhar was frustrated at this time because of the lack of acceptance at Cambridge for his theory about the fate of high mass stars. He took a position as research associate at the University of Chicago in USA and remained affiliated with the university for the rest of his life. He became an eminent professor there. He continued his work on the limits of white dwarf formation for 2 years. Then he drew a line under it and moved on. And this was the pattern of his research work for the rest of his career. He would master a field, publish groundbreaking research in it, then he will move on to another subject. In 1952, he became managing editor of the Astrophysics Journal, remaining in this highly demanding role until 1971, building it from a rather small publication into the foremost international journal of astrophysics. This period was one of the enormous commitments for Chandrasekhar because he continued his research work, his writing, and his university teaching, maintaining his usual very high standards in all these roles, while at the same time managing and building the journal. In the end, scientists came to accept that Chandrasekhar was correct and Eddington was wrong. This was a very slow process because it has taken nearly 30 years for them to accept this. It is now accepted that the ultimate fate of stars depends on their masses. Smaller stars become white dwarfs, while larger stars after a supernova can become neutron stars or black holes. In 1983, Chandrasekhar was awarded the Nobel Prize in Physics for his theoretical studies of the physical process of importance to the structure and evolution of the stars. He shared the prize with William Fowler. Subramanyan Chandrasekhar died of a heart attack on August 21, 1995, aged 84. He retired from his role as a professor at the University of Chicago in 1980. He continued living in Chicago and his output of scientific books continued. His final book was Newton's Principia for the Common Reader, which is a masterpiece published shortly before his death. He was survived by his wife Lalita, who died in 2013 at the age of 102. Today, NASA's Chandra X-ray Observatory is named in his honor, orbits the Earth. This observatory has lived up to his name, discovering new black holes, new supermassive black holes, and a new class of black hole. And this is a short biography about him. If you have anything more to add on to what I've said, please write it in the comment box, like the video, share it with your friends, and if you have not subscribed my channel, please subscribe and support. Thank you.